This demonstration uses Lissajous figures from physics and an interval recognition technique from music to determine frequency ratios for the just diatonic scale or scale of just intonation. First, we introduce Lissajous figures as a game. Here, instructions are given for horizontal and vertical movements that must be followed on the game board as the motion plays out in time. The game is divided into 4 time quarters like football or basketball. Each quarter consists of 4 time blocks or units. First, we decide where to start. In this case, according to the horizontal instructions at t equals 0, we are neither east nor west. The vertical instructions also indicate that we are neither north nor south, so we start at the center of the game board. For the first quarter, we must move east 4 blocks and at the same time north by 4 blocks, so we move northeast along a diagonal. For the second quarter, we come back to the center point. The third quarter requires us to move west and south. Now use your artistic right brain to determine what happens during the last quarter. We return to the center. How many times do we hit the ceiling? Once. At the right upper corner, how many times do we touch the right wall? Once. So the ratio of the vertical to horizontal frequencies is 1 to 1. We already knew this from the instruction graphs. Next, consider a 1 to 1 ratio, but with the vertical wave shifted right by a quarter wavelength, that is by 4 time blocks. We now start south, but neither east nor west. For the first quarter, we move northeast and go to first base. For the second quarter of the game, we continue to go north, but now west. We arrive at second base. The third quarter requires us to keep moving west, but at the same time south, so we wind up at third base. We can use our artistic sense of symmetry to complete the figure by coming home. We have a baseball diamond. Once again, we touch the ceiling once and the right wall once. The vertical to horizontal frequency ratio is again 1 to 1, as we know from the instructions. Finally, we consider a game where the vertical frequency does not equal the horizontal frequency. We take the vertical frequency to be twice that of the horizontal frequency, so that the ratio is 2 to 1. Note that for the vertical wave, 2 complete wavelengths, technically periods, fit in the 16-block time frame, while only 1 complete period occurs for the horizontal wave. We start in the center and drift eastward going up and down for the first quarter. Then we go west and down and up for the second quarter. The third quarter tells us to keep going west as we go up and down. From the symmetry, we can fill in the last quarter, and it checks out, of course, with the instructions. We touch the ceiling twice and the right wall once, which means that the frequency ratio of the vertical to the horizontal is 2 to 1, as we already know. We would like to determine the simplest whole number frequency ratios for the major scale. Such a scale is said to have just intonation. Now we proceed to ear training, a musical technique, which will be very important as we identify musical intervals by hearing the tones. The trick is to associate a key song with each interval. Here are our intervals and key songs. A summary of the key songs for the intervals are shown in the table. There are 8 intervals and 8 songs. Our last step will be the experiment where we bring physics and music together. The unison, this is our do. Note that the 90-degree phase shift quarter wavelength gives us a circle. Our patterns are curved since we are using sine waves instead of triangle waves. The next simplest case is 2 to 1. We find that the interval corresponds to somewhere over the rainbow, the octave. Our scale therefore ranges from 240 Hz to 480 Hz. Let's search for a nice Lissajous figure. Here is one. The 3:2 ratio. The song is Twinkle Twinkle Little Star, the 5th. Note that in some cases, the Lissajous figure is folded, as when the vertical frequency is equal to 400 Hz. Choosing a different phase unfolds the pattern. This case is 5:3, My Bonnie, the 6th. Here are the results. Measuring the 9:8 and 15:8 cases can be a little challenging. The whole number frequency ratios for the just major scale are shown here along with a specific set of frequencies starting with 240 Hz. The last row gives the equal tempered values, which we use today so that transposing to other keys is optimized. Our experiment uses both physics and music where each needs the other. In its best form, science and art are indistinguishable.